Good afternoon, students. In the previous class we have learnt about polarization, polarizability, polarizing power, etc. Okay. So today let us study Paget's rules. Now what are the Paget's rules? Okay. The factors affecting polarization of anion by a cation that was given by Paget's rules. You know that cation can polarize an anion. Okay, so when cation polarizes an anion, that depends on a number of factors. Okay, so let us see the first factor under Paget's rule. It is size of cation. As the size of cation decreases, its polarizing power increases. This you know already. Okay, in the previous class. The size of cation decreases, its polarizing power increases. Okay, this causes higher amount of polarization of anions. So as a result, there will be higher amount of polarization of anions taking place. Now example, among sodium chloride, potassium chloride, rubidium chloride, the size of cations decreases in the order rubidium, potassium and sodium ion. Okay, this is the order. So sodium is having least size, next comes potassium, and then highest size is rubidium. Okay, next slide. Second point, charge on the cation. As the charge of the cation increases, its polarizing power increases. So as the charge increases, polarizing power also increases. Example, among sodium, magnesium, aluminum, the polarizing power increases in the order sodium, magnesium, aluminum. So among these, aluminum is having highest charge, correct? Aluminum 3 plus. Next comes magnesium 2 plus. Okay, and next comes least comes sodium 1 plus. Alright. Now as the charge increases, you can see here charge of aluminum is more, so it has got high polarizing power. Now what is the diagonal relationship? The polarizing power increases with increase in charge and decrease in size. So size decreases, as the size decreases and charge increases, polarizing power also increases. Okay. Now it depends upon increase in charge by radius. Okay, decrease in size, with increase in charge and decrease in size taking place, that is increase in charge by radius ratio. Okay. Lithium ion Li plus and magnesium ion, charge by radius ratio is 1 by 14, or magnesium 2 plus, charge by radius ratio is 2 by 14. 2 by 14 is nearly equal to 1 by 14 only. Okay, so this is known as a diagonal relationship. Next slide, third point, size of anion. As the size of anion increases, its polarizability increases. Okay, so as the size of anion increases, polarizability increases. Now what is the order of halide ions? Iodide having highest size. Okay, next comes bromine, next fluorine, next fluorine. Our least is fluorine. So among the halide ion, the size increases in the order. This you know that fluorine is the topmost under halogens. Okay, iodine is the bottommost. So covalent character of sodium halides increases in the order. So covalent character increases in the order sodium fluoride, sodium chloride, sodium bromide and sodium iodide. Okay. Next slide. Charge on the anion. Fourth point is charge on the anion. The polarizability of anion increases with increase in charge on the anion. So as the size of the anion, okay, you know that the polarizability increases. So polarization of anion increases with the charge also. So it increases with the charge on the anion also. So you know that F minus, O2 minus and N3 minus. Okay, the charge of nitrogen N minus, that is 3 minus. Okay, so as the charge increases, the polarizability anion also increases. So this is the order. So fluoride least charge, least polarizable, next comes O2 minus, next comes nitrogen N3 minus. Okay. Fifth point, electronic configuration of the cation. Pseudo inert gas configuration, that is S2, P6 and D10. This configuration is called, this is the outer electronic configuration. This configuration is called pseudo inert gas configuration. Okay, has higher polarizing power. See, so the elements which have got pseudo inert gas configuration have got high polarizing power than the cation with the inert gas configuration. So inert gas configuration is S2P6, or in other words octet structure. Okay, so outer electronic configuration of inert gas is S2P6. So polarizing power of pseudo inert gas configuration, they have got high polarizing power compared to inert gas configuration. Okay, next slide. Now what is the reason for this? An inert gas configuration is more effective in shielding the nuclear charge than the pseudo inert gas configuration. So inert gas compound or inert gas configuration is more effective in shielding nuclear charge than the pseudo inert gas compound. Therefore, cations not having inert gas compound will have higher effective nuclear charge and hence high polarizing power. So the elements which do not have inert gas configuration will have high effective nuclear charge, and therefore they have got high polarizing power. Example, one example is calcium and mercury. Calcium has got pseudo this inert gas configuration S2P6, whereas mercury 2+ has got pseudo inert gas configuration. You can see here S2P6 D10. Okay, calcium inert gas configuration S2P6 have same size and charge. Mercury chloride is found to be more covalent than calcium chloride because it has got pseudo inert gas configuration. Melting point of mercury chloride is lower than that of calcium chloride. Okay, this is why the melting point of mercury chloride is lower than that of calcium chloride. Okay, because mercury chloride is more covalent than calcium chloride. Next slide. Consequences of polarization. Okay, now let us see what are the consequences of polarization. Okay, melting point. First one is melting point. As the polarization increases, covalent character of the compound increases. You know that as polarization increases, covalent character of compound increases. Okay, as the covalent character increases, melting point decreases. So covalent character and melting point are related. As the covalent character increases, melting point decreases. Okay. Among sodium bromide, magnesium bromide, aluminum bromide, melting point decreases in the order. So among this, melting point decreases in the order. Sodium bromide, highest melting point, magnesium bromide, next least comes aluminum bromide. Okay. More covalent character exhibited by aluminum bromide. Okay. Because the cation charge increases in the order sodium, barium and aluminum, and the polarizing power increases in the same order. Okay. Next slide. Second point, as the size of anion increases, its polarizability increases. So polarizability depends on size of anion also. As the size of anion increases, polarizability increases. Among halide ions, the size increases in the order. What is the order of increase in size among halide ions? Iodine. Iodine is the biggest size. Okay. Next comes bromine, next fluorine, next fluorine. Okay. If you consider negative ions, iodide having highest charge. Okay, highest size. So lithium chloride, lithium fluoride, lithium chloride, lithium bromide, lithium iodide. Hence this is the order. Hence melting point decreases in the order. Okay, so melting point of lithium fluoride is highest. Next comes lithium chloride, next comes lithium bromide, lithium iodide. So lithium iodide is having most covalent character. Okay. Next, third point, both cadmium and lead have high polarizing power because of poor shield effect of d electrons. Okay. So cadmium and lead have got high polarizing power due to the poor shielding effect of d, because these are d orbital electrons or d orbital elements. Now hence cadmium carbonate and lead carbonate have low melting point. Okay. Now next, second point, solubility of salts in water or polar solvents. The solubility of a salt in polar solvent decreases with increase in polarization. So solubility of a salt in polar solvent decreases as polarization increases because the covalent character increases with increase in polarization. So as the polarization increases, covalent character increases. Okay, covalent character increases. Example, water solubility of silver halides decreases in the order silver fluoride greater than silver chloride, greater than silver bromide, and greater than silver iodide. So polarizability decreases with decrease in size of the anion. So polarizability decreases with a decrease in size. So iodide having more polarizing power. Okay, highest size. Next comes bromide, next chloride, next fluoride. Okay, covalent character decreases in the order. Therefore, covalent character decreases in the same order. Okay, next slide. Thermal decomposition of carbonates. Decomposition of carbonates occurs when the cation polarizes carbonate ion, splitting it into O2 minus and carbon dioxide. When a decomposition of carbonate occurs, you get one carbonate ion. And the cation polarizes occurs when the cation polarizes, it splits up into O2 minus and then carbon dioxide. CO3 2 minus ion splits up into O2 minus and then CO2. As the polarization increases, decomposition occurs more readily or thermostability decreases. So, as the polarization increases, decomposition occurs more readily or thermostability decreases. Next, polarization increases with the decrease in size. So, as the size decreases, polarization increases. So, what is the order among alkali and alkaline earth metals? One of the examples is given. Barium 2 plus, bottommost, next strontium, next comes calcium, next magnesium, and uppermost element in the periodic table is beryllium. This is the order: beryllium, magnesium, calcium, strontium, barium. Barium is having highest size. So polarization increases with the decrease in size of the cation. In the case of anions, it increases with size, whereas in the case of cations, it decreases in size. Barium carbonate is thermally more stable than calcium carbonate, which in turn more stable than magnesium carbonate. Next slide. Now let us see what is metallic bond. So in simple words, metallic bond is nothing but bond exists in metals. So metals differ from other elements due to their special properties like high electrical and thermal conductivity. Malleability and ductility, bright luster, and then high tensile strength. These are the special characteristic features of what? Metals. High electrical conductivity and thermal conductivity. They are malleable. Metals are malleable and ductile. And then they have got bright luster, shining surface. And then high tensile strength. They are strong, very strong. Next slide. Band theory or molecular orbital theory of metallic bonds. So there is a theory to explain metallic bonds. Formation of metallic bond. That theory is known as the molecular orbital theory or band theory. Now what is the first postulate of band theory? Band theory is based on the formation of molecular orbitals by the combination of atomic orbitals of metal atoms. So you know that molecular orbitals are formed by the combination of atomic orbitals. So band theory is based on the formation of molecular orbitals by the combination of atomic orbitals. Then second postulate, atomic orbitals of same energy and same symmetry combine together to form same number of molecular orbitals. So atomic orbitals of same energy and then same symmetry and same energy combine to form same number of molecular orbitals. Third point, when the number of atomic orbitals that combine increase, the number of molecular orbitals formed increases and the energy gap between them decreases. So when the number of atomic orbitals combine increase, then the number of molecular formed also increases, because that depends upon the combination of atomic orbitals, right? Molecular orbitals are formed by the combination of atomic orbitals, correct? So when the number of molecular increases, that means what? Number of atomic orbitals combines also increases. So the energy gap between them decreases. So that the energy gap between them decreases. Then next point, the metal is formed by the union of large number of metal atoms. How a metal is formed? By the union of large number of metal atoms. Alright. Hence large number of atomic orbitals combine forming bands of molecular orbitals. So when large number of atomic combine, you get what? Bands. You get bands of molecular orbitals. Next postulate. The inner atomic orbitals are fully filled, the bands formed them is fully filled. If inner atomic orbitals are fully filled, then bands formed them is also fully filled. Such a band is called non-conduction band. So fully filled band is called non-conduction band. The bands formed from valential orbitals may be partially filled or vacant. Such a band is called a conduction band. Whenever there is half filled or partially filled or vacant orbitals are present in valential, okay, then that is formed as conduction band. Okay, that is called conduction band. Next slide. Explanation of electrical conductivity and thermal conductivity of metals based on band theory. Now let us see how to explain electrical conductivity and thermal conductivity based on what? Band theory. Okay. Now metal contains fully filled non-conduction band. You know that metals contain fully filled non-conduction band and partially filled or vacant conduction band. Okay. There exists large energy gap between forbidden, that is called forbidden energy gap. So in between the conduction band and non-conduction band there is a large energy gap. Okay, that is called forbidden energy gap. The conduction band is partially filled and the electrons present here can move to a higher energy levels with the absorption of very small amount of energy. Okay. So these electrons start moving throughout the metal conducting electricity or heat. Since conduction band contains either partially filled orbitals, okay, or we can sometimes vacant also. So when the electrons present, okay, they jump to higher orbital. Here they can jump to higher energy and move throughout the metal. Okay. So as a result, there will be conducting electricity. Okay, they conduct electricity. Next slide, you can see here energy. Okay, energy along the y-axis. You can see forbidden energy gap, large gap between partially filled conduction band and fully filled conduction band. So this indicates the horizontal lines, complete horizontal lines indicates one, it is fully filled. Partial horizontal lines indicates one, partially filled conduction band. This is the conduction band, this is the fully filled band, or it is non-conduction band, and this energy gap is called forbidden energy gap. Okay. Next slide. Example 1. Alkali metal atom like lithium contain half filled Ns orbital. Alkali metal lithium, what is the atomic number? 3. Okay. So 1s2, 2s1. Okay. Total 3. So it has a vacant Np orbital. So p orbital is vacant. Correct. So when these atoms combine together, the lower energy orbitals form non-conduction band. Okay, so lower energy orbitals they form one non-conduction band. Okay, so this is non-conduction because fully filled. So 1s2 is fully filled. Next vacant is 1, 2s1 and p orbital. Okay, so this is partially filled. Okay. Next slide. Insulators. Now let us say what are insulators. Insulators like diamond contain fully filled non-conduction band. So you can see here diamond contains fully filled non-conduction band and vacant conduction band. You can see here vacant conduction. But there is a large energy gap. This is the energy gap between the two. Okay, energy gap between the two. So there exists energy gap between the two. So this is called forbidden energy gap. So there is a large energy gap between non-conduction band and the conduction band. You can see here. Okay. Next slide. Semiconductors like silicon and germanium, the energy gap between non-conduction band and conduction band is small. You can see here. This is a non-conduction band, lower one, upper one is conduction band which is vacant, completely vacant, and you can see here there is a small energy gap between the two. Okay, so this happens in semiconductors. So as the temperature is raised, the conductivity of semiconductor increases due to the excitation of more number of electrons to the conduction band. What happens in the case of semiconductors, as when you raise the temperature, the electrons, okay, they jump from the non-conduction band to the conduction band. Okay, more number of electrons, excitation of more number of electrons to the conduction band takes place. Okay, so from non-conduction band it jumps to the conduction. As a result, they conduct what? Electricity. Okay, semiconductors, electricity, because there is a small energy gap between the two. Okay, so with this chapter is over. Alright, so please go through all the slides. Okay, so any doubts in following, please contact me. Okay, thank you.